Hey, lady, what is this?
Hey, everybody, and welcome to your show and tell. Every week on Wednesdays, 7:30 p.m. Eastern Time. I hope you all set your clocks back and all that good stuff. So you're here at 7:30. And it's dark out, but inside we have the warmth of making and creating and sharing. And that's what we're going to be doing for the next half an hour. Show off what you're making, crafting, 3D printing, sewing, trellising, coding. And we'll all check it out and be like, wow, that's awesome and amazing. And you'll feel really good about yourself. And we're going to get out of here at 7:50. So we'll call on you, unmute your mic, show something off like 2 to 3 minutes. We can get to everybody. And then we'll move on to the next person. Start off with some Adafruit folks with Scott first.
Hello. Thanks for having me, as always.
Of course.
I've been doing USB. I have been doing USB. I'm moving CircuitPython to a shared USB stack for all of our different MCUs that we work on, and I've been polishing that up. So that's super exciting. The thing that I wanted to show is that I use the Beagle 12, which we do carry, to intercept the USB traffic so I can see whether it's correct or not. And their data center app is really, really good for the lowest level of USB. But it's really, it's less good for the higher level, like I'm doing a USB drive or I'm doing audio or I'm doing that sort of stuff. And that's because they don't interpret the packets for you on your behalf. But there's this open source project called Wireshark, which is the tool to understand packets of all sorts. And back when I was doing,
And it's free.
And it's free. And so back ages ago when I was doing USB before, I wrote the script that would take a dump from the data center app from Beagle, convert it over so that Wireshark could use it, which was helpful but still kind of painful. So I on Friday I went in and hooked it up directly so I can use Wireshark to capture from the Beagle directly. So you should, I realized the font's small. I actually just increased it. So we'll see what happens when I select it. But under here, there's a capture menu. And now I can select Beagle 0, which is the only one I have plugged in. So if I double tap that, I don't get anything. But if I connect my USB device that's going through the Beagle, I get, oh, it's giant.
Gigantic fonts. Big packets.
Well, at least you can read that. You can see it's changing, so it's getting live data. And if I click in, you can see that it's taken the packet and interpreted it for me. So I can say, oh, that's USB mass storage, and this is the status of it. I realize that the font is gigantic, so it doesn't tell you that much.
I actually like it. It's like very friendly.
The giant font?
Yeah, I feel like it's my friend.
Yeah, well, yeah, you know, screen sharing, it's like you want to make sure people can actually read it. So I will change it back. I will not, it's at like 36. I won't leave it at that.
Well, we see the bytes, so we know it's real.
Yeah, so if people are interested in debugging their stuff and they want to help me with this, because it's super early, it's super hacky, if I close it, I'll have to force quit the app. But, you know, it works for a demo. And it does help. It works well enough that it does help me debug, which is good. So if you're interested, ping me on Discord. Love help on it.
Okay. Nice work, Scott. Nice work, Scott. Next up, Phil B, Paint Your Dragon.
Hello there.
Dragon in this week.
I was not here last week, and I just realized I have not gone back to watch Show and Tell from last week. Was there like cool Halloween stuff going on?
There's always cool Halloween stuff.
I got to go watch that.
There's also gonna be like cool Halloween stuff next week too. Like, kind of never stops. So.
Yeah. No, I'm already getting started for Halloween. Halloween has started. Halloween 2019 has already started. Anyway, before Halloween, I had done a couple updates to the iCode. You know, because like, you know, certain bands, they do a concert and they have to play a certain song, or just people will walk out. It's like, I'm going to be doing these eyeballs like forever, I think.
Yeah.
So
the NeoPixel library update.
Yeah, so one of the projects was using 2 Hallowings and keeping the blinky eyes in sync. So they look the same way, they blink the same direction. And that was just, it was a small update to the code. And then you use the little I2C cable between the two, and they stay in sync. So that was one project. And then another one using a single Halloween. You could run the same code on too. It's a googly eye, like those rattly things that you get at Michael's, or you know, like cheesy birthday cards always have them in there. So it's a software version of that. Instead of just going into Michael's and getting googly eyes, you know.
Well, I mean, this you want one immediately, and this is you can just build your own,
Exactly.
and it's glowy.
Yeah, no, I'm being snarky. Of course, you want a digital googly eye. I mean, it's the ultimate in technology, right?
Yes.
So that was a second project. There's two new guides on the learning system with the code for these. That's what I had going on.
Okay. All right. Well, you did some great guides that people can follow along. If you have Hallowing or Hallowings, you can make the googly eye or the sync eyes.
More eyes. He just does eyes.
He just does
He
eyes.
just does eyes. Okay. Next,
Noe and Pedro.
Noe and Pedro, what you
in
got
the
going on?
garage. Hey, folks.
Hello.
Hello.
This week we 3D printed a bike light with some NeoPixels. It's over here. Let me turn it on. So this is the handlebars, and I have this 3D printed light diffuser thing that's still extruded. So I have like this nice translucent filament going on the edge. When I turn it on, we get some nice kind of effect. It's kind of bright, so I wish you could see the details in there, but it's pretty nice. It's feather based, so we have the feather and the battery, toggle switch, and this really cool RGB LED push button. Cool thing about the push button is it has an RGB LED, so you can make it so that it matches the NeoPixel. So when you push the button, it can change the colors, and the LED, the RGB LED, will match the NeoPixels. Very, very cool. We have a learn guide that's up, so you guys can check it out. It's got full build instructions, code, and circuit diagram.
Cool.
So, nice, and thank you, Lamar, for putting it together. You know, when you wrote the code, it was my birthday, and that was like the best birthday gift I got.
Oh, happy birthday.
Yeah.
I didn't know that, but I you know what? Every day I try to make the code I write for y'all the best code ever. So it's like every day's a birthday.
Awesome. Very much needed. Yes. So check it out if you guys want to make your own. The files are up there for you guys to print your own or modify it for other things, like maybe a scooter or something like that, or you can just put it on your persons. It's pretty nice.
Yeah, and this is using Phil B's fancy LED code.
Yeah, the fancy LED library. And so, of course, I probably forgot to mention, it is CircuitPython, so I can plug this into any computer, and the code is there. The libraries are on here. They're right there. I can access them.
It's a Python-powered bicycle.
Mind-blowing.
Well, it's funny that this is actually like a build that like I would have really needed at like Burning Man or something, where it's like, oh no, I want to change my bike light colors to something else, and you can't because you didn't bring his laptop with you, but now you can do it from a phone and stuff. Look at how technology has changed.
All right, we'll be playing the video tonight on Ask an Engineer.
All right, next up, Kattni, what are you glowing?
I am glowing the Trellis M4 Express. When you gave me the first board, it had an Arduino demo on it where you could toggle the LEDs, and I have since then been trying to do the same thing on CircuitPython and have done so.
Good work.
It uses dictionaries to store the status of each LED, so when you press it, it actually stores the fact that it's on or off, and then knows to turn it on or off depending on the current state.
Okay.
And that's
cool.
what I've been working on.
Epic.
I think that'll be a neat demo for kids when they want to learn how to program, because like staring at a screen, like yay, but like putting it on something physical and then like, oh look, this is how a dictionary works, and like, this is how the buttons can light up or not.
Yeah. Absolutely.
Cool.
It's also fun just press buttons.
Yeah.
Okay.
Exactly.
Fun to press. That's the thing with because they're squishy.
No, they're squishy. It's absolutely. Look at how happy she is.
Yeah. It's like the bubble.
Eat your Soylent and press the squishy buttons.
It's like the bubble wrap.
Yeah.
Okay. Next
All
up.
right, JP.
JP.
Hey, that's a cool segue. I have a circus aerial performance coming up that could kind of use a prop that is glowy buttons, and I might have to just get that CircuitPython demo running on a Trellis M4, because that's
There you go.
maybe kind of ideal for the routine I have.
Yeah, do a backflip, spin around, like.
I'll leave it safe.
Yeah.
So last week I had my little friend, the urban vinyl doll Money here, M-U-N-N-Y, and his little tilt sensing and Bluetooth activated action. We now have both the Arduino code for it and CircuitPython code for it. So we have 2 different versions depending on how you want to roll. So that guy makes me happy. You can control him from your phone with the Bluefruit app if you want, or just tip him over to get color changes.
Use our new prop maker wing with a bright LED.
I should mention, it's got a prop maker wing in it. It's stuffed in his foot. And so I put out a guide for that. And I think one of the most valuable tips in it that I don't know if people have tried this before, but cutting these is pretty difficult. It's pretty thick vinyl. If you heat it with a heat gun, life is a lot easier. So that was my kind of vital tip on getting inside of these guys to modify them if it involves cutting. So that's Money. I was at Hackaday Super Conference over this past weekend, Friday, Saturday, and Sunday. Super exciting, fun, hardware hackery type of conference. Lots of great talks, lots of great people doing badge hacks. One of the badges was this main conference badge here, which let me hit run. This is running basic, and I have a little bit of basic code that you can see it listed there. And when I run it, it's actually a name badge. It's got my name on there. Windows-K programmed that to just give us a nice start. There were attachments for it. Some people used their Hallowing because 400 people got the Hallowings. So we saw a lot of those at the conference, and some people found interesting ways to attach those. Someone got a USB keyboard running on this, and I think they were working on trying to type to this, although I haven't found out if that happened or not. And one of the other badges I got was Carrie Scharfglass, who I met a couple of years ago at Maker Faire, made these beautiful badges for DEF CON that are this dragonfly that uses infrared. So when a few of them get near each other, they sync up their patterns. And you can see the glowing a little better if I diffuse it a bit.
Oh, yeah, flickery. Okay.
So lots of badge action there and lots of great talks. They're all on YouTube, so go check out some cool talks. Last thing I wanted to show is a bit of a demo and tease for my live stream tomorrow at 4 o'clock. And that is using the Trellis M4 both as a MIDI key input and using the Analog Devices ADXL343 accelerometer that's built onto the board. We can tip it and do things like pitch shifting and mod wheel. So I've got a demo here of this plugged right into an iPad. See that sort of there without too much reflection. And I'm just going to play a little chord, and you'll see as I tilt it, I'm going to be changing the frequency of a cutoff frequency of a filter. So check it out. And pitch bending. It'd go nuts, right?
CScott is like, this interests me greatly. This is magic.
Why isn't it playing Blade Runner?
Traditional keyboard, you have 2 little wheels to control those 2 particular things often, and you can't perform that with a lot of elan. You know, you can't really freak out and shake the wheel unless you pick up the whole darn keyboard. So I think it's kind of interesting from a performance standpoint, besides just playing the music. So
okay,
yeah, I think it's
tune in tomorrow. We'll talk more.
From Fifth Element, I think. All right, next up here.
Hey, Erin.
Erin.
I have a really simple project that I've been working on this week. It's a little game. I used a Circuit Playground and MakeCode to just code up a little spinner. I couldn't decide what I wanted for dinner, so I made a bunch of choices, and now when I push the button, it plays a little sound, and it'll spin around until it stops on my choice, and it looks like I'm having Mexican tonight. So,
all right.
Yay, ice cream.
Taco Wednesdays.
So it's a real simple little game. Every time I push the button, of course it's going to work now. It'll keep spinning around and let you choose. It's just a real simple project. I use MakeCode, so it's a really good sort of intro project. And I just published a guide on how to do it. And make the pretty lights and blinky sounds, and it's a fun little game.
All right, nice work, Erin. Okay, go get some tacos, and you'll see the write-up, everybody, real soon. Erin.
So it said spinner, what's for dinner? Guess that's the name.
Ooh, that's a good one.
All right, next up, we're gonna go to Ben.
Hey, Ben. Welcome. Unmute your mic. Show us what you got.
Hey guys.
Hey.
This is Me? Hi.
Yeah.
So this is my first show and tell. So hello, everybody. And I wanted to show you guys this product that I've been working on called Arduino bots. So they're these little 3D printed battle bots. And I'm using your guys' Bluefruit and your motor driver board in here. But basically, each of these 3D printed bases, this is kind of what all the robots have in common. And then you have little different 3D printed armor kits that you can slide onto the base, and they just kind of snap on here.
That's a good
and
idea.
you can turn them into, so you turn them into the different little robots. So I've got a couple different ones. So I've got 5 of them now, just different armor kits. So the armor kits are, 5 pieces to print off. They're pretty simple, but they don't really have any functional component. It's all in the base. And then with that, I have an app that goes along with it. So you can connect to your robot in the app, and then you can battle each other. So they have working hit sensors. The hammers actually work. So you can go ahead and hit your other robots. So you can pair them up together and battle your friends with your little robots.
All right.
These are great. Well, email support@adafruit.com and we'll send you a sticker that can be battled on or off one of these robots. And if you send an email to pt@adafruit with a link to any of this, if you want to get the word out about it, let me know and I'll blog it up on the site.
Yeah, that'd be awesome. Like this is still kind of a work in progress right now. I emailed you guys about a week ago. I just sent one to support@adafruit.
Oh yeah, email me directly. It might be working its way to me now, but if you could just email pt@adafruit.
pt@adafruit?
Yep.
Yeah, absolutely. Okay. Yeah, I can send you some. I got a kind of a working build guide and
yeah,
initial site up and stuff.
I like this. So BattleBots is interesting because like it got people interested in robotics, but then it drops off really fast. You can't really do anything. And this is a really neat use of 3D printing. You can print the armor, you could do stuff, and then you can learn how to build the things, and you can actually do it. So congratulations, because that's the only thing about BattleBots. Like, well, no one's going to be able to really do that, and if you're doing that, you're like spending $10,000, and it's really tough to do.
Yeah, so you can put these one together for like $100, and they work forever. Basically, the hit sensors all work, and you can do whatever you want.
For schools that have a 3D printer that's doing nothing at all, it's just sitting there gathering dust. That's a good use of a 3D printer. Okay.
All right,
awesome.
Ben.
Thanks, guys.
We're going to go to Adam, and then we're going to wrap up with CScott.
Okay, Adam, what's tiny this week?
Is there anybody can go last?
Oh yeah, sure.
Yeah, thank you.
Okay.
All right, CScott.
CScott, you're next.
Hello.
Hello.
Hey guys, I've been very, very busy this fall, so I haven't been able to do a whole heck of a lot. We just got done with the massive build for the New York keynote a couple of weeks ago, and I'm just now finishing up the project where we build a bunch of kiosks. But I thought I would show you what we've been working on. As soon as I figure out how this thing works, we want to do application window, Google Hangouts, share. You're going to see yourself in a second.
Hello.
But the first one here is there were 30 kiosks built. Each one has 540 NeoPixels in it, which means we had over 16,000 of them. And when you get that many in, some of them aren't going to work. So we end up having to cut these strips of 144 NeoPixels up and join them to get working ones. And I said, you know what? All these leftover pieces that we're left with, we're not going to throw them away. I made a circuit board where I can just lay the strips out and make a nice 16 by 16 display. So that's in the soup. And I mean, you can get. I know you make the grid boards and whatnot that have the little individual pixels already mounted, but I wanted one where you could specifically take the strips and anchor them at either end and power them up and do something with them, give them a second lease on life. Driving those pixels was interesting because the customer had a little Arduino program that ran everything, and the problem was they kind of program like they have a gigabyte of space, and they don't understand that this is an AVR. It's got like scant of a memory, and since they have this like JavaScript packet handler and then 540 LEDs going, it just wasn't going to work. So I had to recode everything to use much less memory, and I decided, well, let's just cram a 1284 in there because it will have some more resources, and I got everything to work. So, you know, it was a bit of a challenge since we were under a bit of a time constraint, you know, because we had 2 projects going at the same time. But it should work out well in the end because we're in the testing phase now.
So that board plugs in an Arduino, like into the socket, and just replaces the dip chip with a TQFP.
Exactly.
Okay, just making sure I understood.
The phase 2 is I'm going to take like your Metro and slap the 1284 on there, and then get some of those made and use them directly in the next iteration of this project. Because, you know, I look around like nobody really makes an Arduino with the 1284. I mean, I've seen various people do little pop sockets like that, like I did.
Yeah.
But I wanted one with a few extra bells and whistles that were specific to the application, and it's gotten cheap enough for third-party manufacturing to get, you know, the necessary number of them put together. So.
All right, sounds cool. Come by when that's done. We'll check it out.
And also, when you're finished and you're not under any time crunch with work, I have a Neo Trellis M4 for you.
Oh, awesome, awesome. I was about to say, you know what that reminds me of? I watched the stuff you did with the synthesizer demo, and I watched this you did this evening. It reminds me of Roger Lynn's Linstrument, which is awesome. I mean, a Linstrument costs a few $1,000s, and it's like 4 feet long, and it's worth every penny. But this gets everybody. You can. The thing that I want to do is you can program it to emulate the frets of the guitar. That's how the Linstrument's based.
Yeah.
And you have the tilt and whatnot to do external modulation effects. Now he uses pressure sensing, but you can kind of work work between those two to get a lot of good Linstrument reactions, even though you don't, unless those buttons are pressure sensitive. If they are, then you know.
No, not yet.
But yeah, work in progress. But yeah, I'll email.
Only when you're done and you know you want to be distracted, drop me a note.
Yeah, I've got some CircuitPython things I want to do, but you know, it'll probably be 2 more weeks, and then you know.
Okay.
All right, good timing.
All right, and back to Adam.
Adam, how's it going?
Hello again. So the reason it has to go last is my microscope's being a bit weird right now. Like buttons are just starting to pop off and whatnot, so it's going great.
Yeah, I know. That's all right.
Like, yeah, there's the cap for a button. It's very critical to actually running them, so it's kind of a toothpick stuck in it. That happened about 5 minutes ago, so that's fine. But right now I've got an e-ink display under the screen that I took apart. It's fairly interesting though, because you can actually see kind of coming up the left-hand side that they have all these different signal rows, and we can pan over to that real quick. I'll zoom out for a second, and then zoom back in. Bring the camera over.
Okay.
You can see we start with all of these different data rows that come up. Then we've got these power buses, and these power buses each go to 1 transistor. And so data row comes up, powers that transistor, and that transistor takes positive or negative relative for one of these buses, and then sends it across this entire, then sends it across to these pixels, and just on an XY grid, so it's multiplexed. And so each one of these pixels has a large conductive area that interfaces with the screen. So through that signal bus, through that transistor, you can vary the polarity of each one of these pixels, and then form the image on screen through some pulse width modulation. But what's also really fun, oh, my camera is super out of focus. That's
Yeah, I was about to say something, but then it went into focus. I'm just like, well.
So this is the chip that is inside the Scantron microscope, and you're looking at that?
Yeah, so this is actually a ink display that's been cracked open. I can grab the display. Just give me a second. So here's the display. This is my old Kindle's display. It suffered a catastrophic failure. A slide rule in my backpack hit it, which is kind of a great way for ink display to go. So I just delayered it. So just took some bits off it and stuck it under here. So each one of these is one of the actual backings to the pixel. So this large area you see on it is the conductive area. But what's also cool is I've got my Microsoft's digital acquisition system working fairly well. So I'm able to capture some significantly nicer images. And this is only a 30-second scan, so it's not great resolution or quality. But later I'll do like a 2 or 3 minute scan on it, and we'll get some really interesting stuff. And this was kind of something I threw into the microscope really quickly because my original plan did fail catastrophically. So I was also at SuperCon this weekend, and Scotty from Stranger Parts gave me some really cool kind of just random stuff for the market. And I got this large pile of reject direct on board chips. And what was interesting, though, is that if you look at these, the edge of these kind of starts to, like, the manufacturing process kind of goes from here to here and slowly kind of fades out. So you've got this in-between layer where there's no passivation present, which means there's no glass layer on top. So my theory was I should be able to image this under the microscope, but I had some contamination issues and didn't have time to clean it off properly. So I had to find something else really quickly to put under the scope. Which, yes, I had I think 10 or so minutes to punt back down before trying to get the machine actually on the air. So, well, live demos.
The ink looks great. Live demo looks good. Yeah, and then next week maybe if you get to clean off those chips, come by, and we'd love to let people love looking at chips under the quantum microscope, and you got one. So
well, I got one more to share real quick. Then, if you guys do have a second.
Yeah.
Cool. This was unfortunately not captured with my microscope. I got to use a brand new microscope at a trade or at a conference recently, and this one's interesting just because of how high resolution it is. So we can pretty much just, it's not downloading full, there we go, just keep on zooming in on this thing, and see some really interesting stuff. But what I did is I ran the beam at a very, very high kV and extracted a specific type of electron that lets me like see through the surface of the chip. So you can actually see kind of, there's some parts that look pretty translucent. So the surface of the chip looks like, as I'm going to shamelessly pull a slide from my talk I gave at SuperCon, is it has all these pitted surfaces and all these kind of details that's a result of the acid etching. But by using this higher kV beam and a special detector, we're able to punch through that and see through it and kind of gather a lot more information about the chip without having to continuously delayer it. And when you have something this high resolution, you can do some really interesting mapping efforts. Like you've got all these kind of like shift register type things here. You've actually got some areas where all these little bright white spots that represent tungsten vias you can be fairly certain they're actually storing data in the chip.
Okay.
Which is always a lot of fun to kind of see those like flags physically set in the silicon.
Okay, so for more information, people can check out your talk. We got to go to the show. Thanks for the update.
Yeah, sorry for sending you somewhere else, but
thanks, Scott. Thanks, Phil. Thanks, Noe and Pedro. Thanks, Kattni. Thanks, JP. Thanks, CScott. Thanks, Adam. Play us out.
Yeah, play us out.
We'll be in. That's good. All right, see you in a couple minutes.
We'll see everybody next week, 7:30 p.m. Eastern Time, and we'll see everyone on Ask an Engineer at 8 p.m. in just a couple minutes. Bye, folks.
Bye, folks.